Hello students. So today we will be discussing a question from PYQ. So in this question, current I is equal to 1 ampere is passing through a copper rod with charge density given. Charge density is 8.5 into 10 power 28 per meter cube, electrons per meter cube, of varying cross section as shown in the figure. The area of cross section at point A and B along its length are 1 into 10 power minus 7 meter square, 2 into 10 power minus 7 meter square respectively. Calculate the ratio of electric fields at point A and B, and also calculate the drift velocity of free electrons at point B. So let's look at the first question here. How do you calculate the ratio of electric fields at point A and B? So we know the current is given. Current is given as 1 ampere, and the number density is given as 8.5 into 10 power 28 just per meter cube. The area of cross section of point A is given as 10 power minus 7 meters square. Area of cross section of point B is given as 2 into 10 power minus 7 meters square. These are given. So how do you find the ratio of electric field? We have to relate this to electric field. Since current and area are given, we know current density can be found out, and current density is related to electric field in the form J is equal to sigma E. Okay. So we know current density is equal to current by area. Current density is equal to current per unit area. Also, what is sigma? Sigma is conductivity, sorry. And conductivity is equal to 1 by resistivity. We know we are talking in this particular conductor, the copper rod, we know that the resistivity is not going to change because resistivity is independent of dimensions. So conductivity is also independent of dimensions because conductivity is just the reciprocal of resistivity. So can I say that current density is directly proportional to electric field in this case? Or I can say electric field at point A by electric field at point B, which we have to find out, is nothing but the ratio of current density at point A by current density at point B. So current density at point A, we know current density is equal to current by area. So current by area at A and current by area at B. We know current is not going to change. So this is simply equal to area at point B by area at point A. And area at point B is 2 into 10 power minus 7 meters square. And area at point A is 10 power minus 7 meters square. So the ratio of electric fields at A and B is just equal to 2:1. This is the answer for the first part. Now for the second part, the drift velocity of the free electrons at point B. How do we find the drift velocity of the electrons at point B? We can find out easily. We know how is drift velocity related to the given values. We have a relation for current and drift velocity, which is given by I is equal to N E A V. Vd is the drift velocity. A is the area of cross section at the point. E is the charge of electron, 1.6 into 10 power minus 19. I is the current. So drift velocity can be written as I by N E A. Current is 1 ampere. Number density is 8.5 into 10 power 28. Electron charge is 1.6 into 10 power minus 19 into area of cross section at, we are talking about drift velocity at point B. So you have to take the area of cross section at point B, which is 2 into 10 power minus 7. Okay. So this is equal to 1 by, I can remove the decimal by taking in the 0 from here. So I can write it as 85 into 10 power 27. Again, this 1.6 into 10 power 19 can be written as 16 into 10 power minus 20 into 2 into 10 power minus 7. Okay. So, uh, If you observe carefully, you can see this is 10 power minus 20 into 10 power minus 7, which is 10 power minus 27. So I can write it as 1 by 85 into 16 into 10 power 27 into 10 power minus 27. So this can be cancelled out. So finally, we have 1 by 85 into 16. Okay. So if you multiply numerator and denominator with 10 power 4, we can make the calculation a bit simpler. Because otherwise, you will have to take the division becomes a bit difficult here. So this will be, I think we forgot the 2 in the denominator as well. There is a 2 as well. So 85 into 16 into 2. So we'll write that 2 here, 2 into 85 into 16. So I can write it as 10 power 4 or 100 into 100 divided by 2 into 85 into 16 into taking this 10 power 4 to the numerator becomes 10 power minus 4. So this I can simplify as 4, 4, 16, 4, 2500, then 5, 525, 5 into 17, 85, 5 into 1785. Then we have this 2 into 50, 100. Okay. So this is 2 into 2, 2 into 25. So we have in the numerator 125, the denominator we have 17 into 2, that is 34 into 10 power minus 4. So if you simplify this 125 over 34, that will be around 3.6. Around 3.6 into 10 power minus 4 meter per second is the drift velocity. So I hope the question is clear. Thank you.